Hello everyone, this is your tutor AB, and today we're going to be taking a look at a projectile motion question. This is from the May 2021 IB examinations and is an IB Physics SO Paper 2 question. It's a 5-part question with a total of 10 marks to take. So let's see how we would solve this question. Let's take a look at this question. A football player kicks a stationary ball of mass 0.45 kg towards a wall. The initial speed of the ball after the kick is 19 meters per second and the ball does not rotate. Air resistance is negligible and there is no wind. So part A. The player's foot is in contact with the ball for 55 milliseconds. Calculate the average force that acts on the ball due to the football player. Okay, so let's see what we have. We have the mass of the ball, we have a velocity of the ball after the kick, and we know that the ball was initially stationary. Now, there are a few ways we can solve this, but I would say the best way to solve this question would be using equations of momentum and impulse. And the reason I say this is because we're given a mass, and this actually indicates that this would be the best way to solve. Otherwise, we could use kinematic equations, but I believe that impulse and momentum is best for this equation, so that's what I'm best for this question, so that's what I'm going to use. So let's recall, what is the formula for impulse? Impulse, denoted by J, is equal to the force, the net force, multiplied into a change in time. So we want to rearrange to solve for force, but of course we don't have impulse, but we can calculate impulse, because what is impulse? Impulse is just a change in momentum, denoted by the variable p. So a change in momentum, and what's the formula for momentum? P is equal to mass into velocity. So we can simply just get the final momentum, PF minus P initial, to get the final impulse, to get the impulse. So let's solve, shall we? So what is the final momentum? It will just be the mass 0.45 kg into the final velocity, which is 19 meters per second. That's the velocity after it was kicked, minus the initial momentum, which is again 0.45 kg, into the stationary. The ball is stationary, so it has no velocity, 0, and that gives us our impulse. So solving this with a calculator, we actually get that impulse J is equal to 8.55. Now then we can use this equation, which we identified at the beginning, to solve for the average force. We have the impulse and we have the change in time, which is 55 milliseconds. So if we rearrange the equation, we can solve for net force. So J over change in T would give us F. So 8.55 over 0.055, because we have to divide 55 milliseconds by 1000 to get seconds, gives us force. And then putting this into a calculator, we get the answer is 155.45 newtons, and that is the average force that acts on the ball due to the football player. And that should be 2 marks, because we've used all the proper equations and showed all our working out and given the correct units, newtons. So that is our final answer for part A. Okay, let's look at part B. The ball leaves the ground at an angle of 22 degrees. The horizontal distance from the initial position of the edge of the ball to the wall is 11 meters. Calculate the time taken for the ball to reach the wall. And this again goes for 2 marks. So what do we do here? We have a resultant velocity, because remember, this is projectile motion. And with any projectile motion question, the resultant velocity can be broken down into components, a vertical and a horizontal component. And so we can break this velocity 19 meters per second square down into a vertical and horizontal component because we are also given an angle. So let's do this, shall we? How do we do this? Well, we have a right angle triangle, and in this right angle triangle, which is approximately how he's kicking the ball, we know he's kicking it at 22 degrees, and we know this is right angle. So we know the resultant velocity, the diagonal velocity, to just understand better, just going that way, is 19 meters per second. Of course, we can now use our trigonometric ratios to get what is the y component, the vertical component, and the x component, the horizontal component. So how do we do this? We have to use our calculators. We have to use both sine and cos theta to find our y and our x. So let's first find our horizontal component because that's what's needed for this question. But let's also find the vertical component because it's possible that it's needed in the future. So how do we find x? Well, we know we are given a hypotenuse and an adjacent side to the angle. And every time we have an adjacent side, we always have to look at cos. So cosine of 22 degrees is equal to the adjacent x over 19. So when we put this in our calculator and rearrange, we get cosine 22 multiplied into 19, and we get a horizontal component of velocity to be equal to 17.6 meters per second. So we can say we can delete this x and replace it in the diagram with our new value 17.6 meters per second. Now let's also get our y component, our vertical component, and every time we're given an opposite side, we know to use sine. So we can use sine of 22, of course the angle is the same, is equal to y over hypotenuse 19. And then now putting this into our calculator, we get 7.11. The vertical component of velocity in this question is now 7.1 meters per second. So what can we do? What do we need to do for this question to get our answer? Well, one major concept in projectile motion that we need to understand is that this horizontal component of velocity always stays constant throughout the motion. And what do we know about when the velocity stays the same? Constant acceleration. We can directly use, or no acceleration in this case, sorry. We can use the equation, the simplest speed, distance, time equation there is. V is equal to distance over time, or otherwise T is equal to distance over speed. And that's directly what we can do in this question because our speed is constant. So time will be given as distance 11 meters, which is given in the question, divided by our y, which is our x, which is 17.6. This would be our time. So putting this into the calculator, we get 11 divided by 17.6, and that gives us 0.625 seconds. So t is equal to 0.625 seconds. And that is the answer for this question. That's how long it's going to take the ball from the initial position to hit the wall. So let's go to the next part. This is now part B2. The top of the wall is 2.4 meters above the ground. Deduce whether the ball will hit the wall. And this goes for 3 marks. This is the biggest part of this whole question. So how do we do this? Well, what did we previously calculate? We calculated by breaking down the components of velocity that the y component, the vertical component of the kicking the ball, is actually equal to 7.1 meters per second. That's what we calculated previously. This was the vertical velocity. Also, we calculated the time it takes to reach the wall. The time it took to reach the wall was 0.625 seconds. This was the time to reach wall. So using these two pieces of information that we calculated in earlier questions, can we solve this question? Well, actually, yes, we can. We can solve this question really quite simply using the kinematic equations. We can use our displacement equation, because we have a velocity, which is our initial velocity, initial vertical velocity. We have a time, and that's really all that we need. So why not use this and see where the position of the ball will be at a time of 0.625 seconds when given a vertical velocity of 7.1 meters per second. So let's put this into our equation. S is equal to 7.1 into t 0.625 ut plus half the acceleration of the ball, which we can say is negative 10 meters per second, into our t square, so 0.625 square. So what does this give us? Let's put this into our calculator, shall we? So we get 7.1 multiplied into 0. We get the first part, which is 4.43 plus negative 5 times 0.39. So when we equate this, we actually get 4.43 minus 1.95, which is 4.43 minus 1.95 gives us an answer of 2.48, or round about 2.5 meters. So what does this tell us? The wall is 2.4 meters long, 2.4 meters in height. And what this tells us is that according to our vertical velocity, in this many seconds, 0.625 seconds, the ball will be at a position of 2.5 meters above the ground. As 2.5 meters is greater than 2.4 meters, we conclude that ball passes the wall, meaning it does not hit the wall, because it is above the wall at the given time. Using our kinematic equations, we have solved this question, and so that is our final answer, and that should be all 3 marks. Let's now look at part C. In practice, air resistance affects the ball. Outline the effect that air resistance has on the vertical acceleration of the ball. Take the direction of the acceleration due to gravity to be positive. Okay, so we need to understand what happens in projectile motion. With an object, when an object is launched into the air, it initially moves upwards and forwards. We know this. However, air resistance works against this motion. Vertically, It reduces the object's upward speed, causing its peak height to reach sooner and making the height lower than it would be in a vacuum. Otherwise, when there is no air resistance. So how do we draw this? Think about it this way. We have a projectile right here. It has, of course, has a vertical component and a horizontal component. In a vacuum, let's say it would go like this. This will be its trajectory, and it will reach somewhere down there. However, with a air resistance, it's going to reach a peak height sooner, and this peak height will also be less than what it should have been in a vacuum. So it'll be something like this. It'd be something like this. That'd be the peak height, and it reached sooner. You can see there's a difference in the peak height because this is the effect of air resistance. So I hope this clears it up, and some sort of answer along these lines would get you the 2 marks for this question. Okay, this is the last part of the question, part D. The player kicks the ball again. It rolls along the ground with a horizontal velocity of 1.4 meters per second. The radius of the ball is 0.11 meters. Calculate the angular velocity of the ball. State an appropriate SI unit for your answer. So finally, how do we answer this last question? Well, we know the formula for angular velocity is W is equal to velocity by the radius. So directly just substituting that in, angular velocity is equal to 1.4 divided by 0.11, which gives us something approximate to 12.72. So again, we can say that's approximately equal to 13. Now we need to understand the measurement for this is 13 radians per second. And that's your final answer.